Calc BC, 4-5 office hours, or 4-4 assignment 4-5. We skipped the 4-4 book assignment and did this instead. The top has some of the different things that we've been talking about in this chapter, and there's some things about it I want you to ignore. Obviously, the dy dx. Now, in general, for dy dx, the thing you should remember is that it's going to be dy d theta over dx d theta, right? Which is where this comes from. Now, at the pole, r is 0. That means this is 0 and that's 0. Those terms drop out. You're left with this. The r primes are going to be the same. And so there's a shortcut we discussed in the previous lesson that tells you that dy dx ends up just being tangent theta, sine over cosine, when r is 0, when you're at the pole. Now, when when you're looking at max r, dr d theta is 0, and that's these guys. So these terms drop out, and you're left with the r's, which cancel, and you have a cosine and every sine. So dy dx in this situation is negative cotangent theta. So those are a couple shortcuts. And that's the only reason I would show you this, is just to help you quickly understand the shortcuts better. But otherwise, for dy dx, you should always use that. So just some helpful things. And these problems are just kind of, giving you some practice. Let's see, the following functions are 2 pi. Find the values where r is maximized, the slope of the curve when r is maximized, where the graph is vertical, horizontal, and the slope of the graph at the pole. So we're going to do a quick sketch of these. You should, hopefully by now recognize that this is a circle, and it should be vertical because of the sign. Do a quick sketch, and that's going to help us make sense of all the answers we're going to be getting, how many, where they should be. So 0, 1, 0, -1, 0. And so quick sketch. Zero, 0, pi over 2, 1. So the radius is half of that. The diameter is 1. This is what the graph looks like. So all our answers should be a little more obvious based off that. Okay, so A, we're looking for the values where r is maximized, which there are really no endpoints on these, but the values keep repeating. So we can we could do EVT anyways, but we got to find drd theta, which is going to be cosine theta, set it equal to 0 undefined, find critical points. So theta equals pi over 2 plus pi k. So theta equals pi over 2 and 3 pi over 2. And we could do a quick table, EVT. And we're going 0 to 2 pi. So if you plug 0 into r, which is sine theta, you get 0, 1, -1, and 0. So the maximum radius is there. The minimum radius is there. So we're going to say max r equals 1 at theta equals pi over 2. Okay. So part B says the slope of the polar curve when r is maximized. Now this is where we could use that shortcut that I was talking about. I mean, we could do it the long way. The long way would be to just do it the way we would do it for any other point. dy dx equals dy d theta over dx d theta. We should probably write what x and r are somewhere. Let's just write them right here. X equals r cosine theta, which is going to be sine theta cosine theta. And y equals r sine theta, which is going to be sine squared, right? So this is going to give you 2 sine cosine on the top, And the bottom is going to give you sine theta times negative sine theta plus cosine theta times cosine theta. So if we plug pi over 2 into this, and by the way, we could also look at this graph. This is where the slope is. It should come out to 0. I still want to see the work, but you should know it's going to be 0, right? And that max radius makes sense on the picture too, furthest away from that pole. So if you plug pi over 2 into this, you get 2, 1, 0 over 1, negative 1, or 1 times negative 1 plus 0 times 0. So you get 0 over negative 1, which is 0 for the slope at the maximum radius. Now the shortcut would be to use tangent theta. And in that case, you would jump to sine of pi over 2 is 1 over cosine pi over 2 is 0. Oh, shoot, no, sorry. Sine of pi over 2 is... Oh, no. It wouldn't be tangent because we're not at the pole. It would be negative cotangent. So it would be negative cosine pi over 2 is 0 over that, and you would get 0 that way too. So it's up to you. Okay. C. Find the values with the graph is vertical. Now in the picture, it looks like it's here and here. It looks like there's 2 spots. It would be this angle in the first quadrant, this angle in the second quadrant. I guess it happens again 2 more times if we're considering all the values between 0 and 2 pi. But it is going to be when dy dx equals 0, and more specifically, dx d theta equals 0. And so dx d theta is sine times negative sine plus cosine times cosine. We'll product rule real quick. So that's going to be 0 equals negative sine squared plus cosine squared. So, I mean, it depends on how you want to solve this, but it's going to be when sine squared equals cosine squared. So when do they give you the same value? Well, that would be reference angle of pi over 4, and it'd be all the quadrants, 1, 2, 3, 4, because they get squared. So even in quadrants where one's positive, one's negative, if you square them both, they're going to be equal. So that should happen at theta equals pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Now, on our picture, that looks like pi over 4 and 3 pi over 4, and then it would happen again at 5 pi over 4 and 7 pi over 4. Now, if we're worried about, well, what if dy d theta is 0 at the same time, then that's an indeterminate form. Well, that usually is going to happen at like a cusp or something, by the way. So I don't anticipate it happening, but we're going to find it in part D anyway. So if there is an issue, we're going to discover it. And also, yeah. So horizontal would be when, sorry, I was trying to find vertical there. So it was supposed to be undefined. I did the right work after that. Horizontal is 0. And that's when dy d theta equals 0 at the top. Derivative of the top is going to be 2 sine theta cosine theta. Right? And so you divide both sides by 2. It's going to be when is this equal 0? Well, it could be when that equals 0, right? Or it could be when that equals 0. So this is going to be theta equals 0 plus pi k. It's going to be theta equals pi over 2 plus pi k. And by the way, in the picture, horizontal tangents, it looks like it's horizontal here and here. So 2 spots, but I think at 0 it is, and then at 2 pi, you're at the same spot, so it'd be that. And this gets hit twice at least. So I don't know, we might get a bunch of answers, even though it only looks like. So we're going to get 0, pi, 2 pi, and those are all that bottom one. And then pi over 2, 3 pi over 2 is the top one that gets hit twice, because circles get graphed twice. They get repeated if you go 0 to 2 pi. So even though it only looks like there's only 2 physical points on the picture, but there's multiple angles that put you at that same point over and over again. We need to give them all. E says this, and by the way, is there any points that showed up in both of these lists? If there are, then that's an issue that we got to figure out. But there aren't this time. Like I said, it's usually like a cusp where that happens. Slope of the graph, slope of the polar graph at the pole. So we got to figure out, well, when is it at the pole? In this one, we might be able to just tell from our graph, but we could set r equal to 0. And that's going to be at 0 plus pi k. So that's going to be at 0 pi 2 pi. And there's a shortcut, right? That is just going to be tangent. So you could do it the long way. You could do the whole dy d theta over dx d theta. And we already wrote that down, so you could just use that from earlier before and then plug this value in, these values. Now 0 pi and 2 pi, I think, are all give you the same slope. They're all at the pole. And if you look at the pole, the tangent lines are always going to be flat. But so plugging 0 pi and 2 pi into tangents, going to sine over cosine. No matter what, sine's going to be 0, right? And the bottom is going to either be 1 or negative 1. It's going to come out to 0. So, okay. Next one is cardioid. So we do a quick sketch. Should be horizontal. And so it's going to be 2, 1, 0, 1, 2. It's bigger to the right, sideways. So 0, 2, pi over 2, 1, pi 0, 3 pi over 2, 1, 2 pi 0. It'll look like this. Okay. X equals our cosine theta, which is going to be 1 plus cosine theta. And y equals r sine theta, which is going to be 1 plus cosine theta sine theta. And yeah, so A says, let's find when R is maximized. Now, in my picture, I think it's right here, which is at angle 0 or 2 pi. Now, I'm going to verify that. Drd theta equals negative sine theta, so equals 0 undefined. Find critical points. So theta equals 0 plus pi k. So theta equals 0 pi 2 pi. Now, if we did a quick little table, which we actually have all these values in here already. So here's the min value. So this is the way you find the min and the maxes. Min, of course, is at the pole. Mostly a lot of these graphs. So the max R equals 2 at theta equals 0 and 2 pi. All right, so that's A. Okay. So let's see. B, we're looking for the slope of the polar curve when it's maximized. So we could use the shortcut dy dx equals negative cotangent theta. So it's going to be negative cosine over sine. And so that's going to be when you plug 0, 2 pi, and it's going to give you the same thing. It's going to be negative 1 over 0, which is going to be undefined. Now, based off the picture, does that make sense? That the slope of the max R is undefined? Yes, it does. Okay. C, values of slope on the graph is vertical, so that's going to be when dy dx equals undefined, which is going to be when dx d theta equals 0. And so dx d theta is going to be 1 plus cosine theta negative sine theta plus cosine theta times negative sine theta. And so we could factor that I think we take a negative sine theta out of both of them, and then you have 1 plus 2 cosine theta equals 0. So sine theta equals 0, and cosine theta equals negative 1/2. So theta equals 0 plus pi k. And over here, theta equals is going to be alpha equals pi over 3, quadrants 2 and 3, or it's negative, so it's going to be 2 pi over 3 and 4 pi over 3. Now, let's see. So we're going to get theta equals 0, pi, and 2 pi. So it looks like we have 5 values, but we're looking for horizontal, no, vertical tangent. So here, here, and here. 0, this one's going to be your 2 pi over 3. This one's going to be your 4 pi over 3. But pi doesn't make sense. Pi, I think, is horizontal based off the picture. And so we're probably going to get rid of that one. It's going to come up on the next one. Now, I'm okay with you guys just saying, you know what, based off the picture, it's horizontal. And it's going to show up in the next one for the horizontal ones. And you'll be like, yep, that is what the case is. So horizontal, it's going to be when the slope equals 0. So it's when dy d theta equals 0. And so the derivative of y, it's going to be 1 plus cosine theta plus sine theta, and negative sine theta. And so that's going to be cosine theta plus cosine theta squared minus sine squared. Pythagorean identity, we could replace this with 1 minus cosine squared theta. Distribute the negative, so we get 0 equals 2 cosine squared theta plus cosine theta minus 1. And we factor it. Like a trinomial, 1 and 1, negative, positive. So cosine theta equals positive 1/2. Cosine theta equals negative 1. Reference angle is pi over 3. Quadrants 1 and 4. So theta equals pi over 3. 5 pi over 3. Here theta equals pi plus 2 pi k. And so pi, so we get these 3 answers. Now on the graph, looks like there's one right here at pi over 3. Looks like there's one down here at 5 pi over 3. And it looks like there's one right here at the cusp at pi. So that, like I said, the pi is going to show up on both of those at that cusp. So E, the slope of the polar graph at the pole. So we got to figure out when is it at the pole. And so we're going to set R equal to 0. And let's see. So that's going to be pi plus 2 pi k. So it's going to be pi. And then the shortcut for the slope is that you just get tangent, which is sine over cosine. So dy dx at theta equals pi is going to be sine pi, which is 0, over cosine pi, which is negative 1, which is 0. Which, if we look at the picture, that's what we concluded, right? Just on part D, that at pi, we got a horizontal tangent. Okay. So we're doing the same things on these ones on the back. Okay, so this is a rose curve, rose petals, whatever, and the radius is 1. I'm not going to do a table for these ones. I'm going to sketch the radius of one circle real quick. All right, lightly dashed. Okay, and then we're going to figure out where the tips of the Rose curve is. So we're going to set the radius equal plus or minus 1, the extreme radius. So that's going to be 2 theta equals pi over 2 plus pi k. And so theta equals pi over 4 plus pi over 2k. And so we get theta equals, now by the way, we should have 4 petals because it's an even number, so you get double. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so we're going to sketch the pi over 4 angles in all the way through, and the angles that cut them in half are already there in the form of the axes. So the first petal starts here, positive, and then the next one's at 3 pi over 4, but it's negative, so it's back here. And the next one's at 5 pi over 4, but it's positive, so it's right there. It's the third one, and the last one is at 7 pi over 4, but it's negative, so it's back here. So it's going to go like this: 1, 2, 3, 4. Okay. X equals r cosine theta, so it's going to be sine 2 theta cosine theta, and y equals r sine theta, so it's going to be sine 2 theta sine theta. So we use those, and so for A, we're looking for max r, so we're going to do dr d theta, which is going to be the same thing as r prime, by the way, which is going to be 2 cosine 2 theta. We say equals 0 and define critical points. So cosine 2 theta equals 0. So 2 theta equals pi over 2 plus pi k. And theta equals pi over 4 plus pi over 2k. And this should look familiar because this is actually the max r's are the ends of the tips of the flowers, which is what we already found to graph it. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So we actually expect all of these to be the locations because make a table with these. I guess we could put the endpoints in just to make it official. Okay, so if you plug 0 in there, you get 0, and 2 pi, you get 0. Now if you plug pi over 4, you get pi over 2, which is 1. And 3 pi over 4 would be 3 pi over 2, which would be negative 1. And 5 pi over 4, that would be 5 pi over 2, which would be minus pi over 2, which would be 1, and that would be negative 1. So here's your max. And the min radiuses actually happen at those extreme points too, because they're the most negative backwards radiuses. So the max r equals 1 at theta equals pi over 4 and 5 pi over 4 by extreme value theorem. Okay, B, we're looking for the slope at those points. So we could use a little shortcut. For max r, it's going to be negative cotangent theta. So it's going to be negative cosine theta over sine theta. And that saves you a little bit of messy work. Not that you have to. Now, so one of these is this one, and then the other one is the third one, which is down here. It looks like they have the same slope. They're different places. So that's going to be negative root 2 over 2 over root 2 over 2 equals negative 1, which seems right? And we do the other one, it's probably going to come out to negative 1 also. So 5 pi over 4. So 5 pi over 4 is quadrant 3. So you get a positive root 2 over 2 on the top because the negative are already there, and a negative root 2 over 2 on the bottom, and a negative 1. So 2 different points, the slopes turn out to be the same. C, we're looking for vertical tangents, right? So vertical tangents, looks like there's got to be one somewhere around here. maybe here, maybe here, maybe here, and probably in the middle several times. So I'm thinking there's going to be a bunch. So it's going to be dy dx equals undefined, which means that dx d theta equals 0. And we might get some interesting things like, I don't know, we'll see. So dx d theta is going to be sine 2 theta negative sine theta plus cosine theta times 2 cosine 2 theta. Ooh, this looks bad. So let's see. This one might be a little fun. To solve this, you really want to get rid of those 2 theta terms altogether. So you use double angle identity, which I'm just going to write it down here. It's been a little while. It's based off of the angle addition identity. So sine of A plus B equals sine A cosine B plus sine B cosine A. So if they're the same angle, theta plus theta, you get sine theta, cosine theta, sine theta, cosine theta. You get 2 sine theta, cosine theta. And then for cosine, the angle addition is it's cosine A cosine B minus sine A sine B. And so when they're the same angle, theta plus theta ends up being cosine squared theta minus sine squared theta. And then you have some options of like changing those into, you could replace the cosine squared with 1 minus sine squared, so you get 1 minus 2 sine squared. You could replace the sine squared with 1 minus cosine squared, so then you get 2 cosine squared minus 1. Those are the versions, just using Pythagorean identity. So we're going to try and use those maybe. So this one's a little hard just because of all the trig stuff involved. So we could replace this. This is going to be negative 2 sine squared cosine theta, because I'm replacing the sine 2 theta with 2 sine cosine, and there's already a negative sign. And then this is going to be one of these. I don't know. I think we want to be able to factor. I mean, we can have sine and cosine as long as the GCF removes one of them. So I'm just trying to anticipate this. Let's see, which one is going to work better? Well, there's a 2 cosine here, and there's 2 cosine here. So let's replace this with the one that's all sine stuff. Okay, so that's going to be plus 2 cosine theta. And I'm just going to leave it in the parentheses. So then we could factor out the negative 2 cosine theta, and there'd be a sine squared here, and then a minus 1 plus 2 sine squared here. So 3 sine squared theta minus 1. So cosine theta equals 0. And then sine squared theta equals 1/3. And you take square root of both sides, plus or minus. So sine theta equals plus or minus root 3 over 3 or whatever, which is not a common angle, we know. So unfortunately, so theta equals inverse sine. If you do the positive one, that's going to give you the reference angle. Okay, that's going to give you quadrant 1. And then you can use that to find all the other quadrants. It's all the quadrants. And so it's going to be, so this is going to be theta equals pi over 2. Theta equals pi over 2 plus pi k. So it's going to be 3 pi over 2. And then these are going to be, first quadrant is going to be inverse sine of root 3 over 3. Try and pull this off without a calculator. Second quadrant is going to be pi minus inverse sine of root 3 over 3. Third quadrant is going to be pi plus inverse sine of root 3 over 3. And fourth quadrant is going to be 2 pi minus inverse sine of root 3 over 3. So this is some tedious. So these are the answers. Okay. Now you could use your calculator and get decimals for those. But those are the exact answers. Pulling it off without a calculator. Now let's see if any of these show up in the other one. So horizontal, we get some fun here. So this is going to be dy dx equals 0. So that means dy d theta equals 0. And dy d theta is going to be sine 2 theta cosine theta plus sine theta to cosine 2 theta. So we're running into the same situation as last time, but we could use the stuff we wrote down here, these double angle trig identities. So we're going to get 2 sine squared theta cosine squared theta. And here you're going to have a 2, I don't know which one we're going to go with here. You have the 2 sine and replace the cosine 2 theta with one of those other ones. I think we're going to do the one with cosine theta. Let's see. Oh, I messed this one up. That should be cosine squared. So we're going to, we want to do that one and replace the cosine with the one with the cosine squared. So 2 cosine squared minus 1. So then we can factor out a 2 sine theta. Then we have a cosine squared theta plus 2 cosine squared theta minus 1. And then we could say, well, that is 3 cosine squared theta minus 1. So it's going to be when sine theta equals 0 and cosine squared theta equals 1/3. You can take the square root of both sides, plus or minus. To get cosine theta equals plus or minus root 3 over 3. Then you could do, well, alpha first quadrant is going to be inverse cosine of positive root 3 over 3. That'll for sure give you the alpha. Quadrant 1 is going to be all the quadrants. So it's going to be theta equals 0. This is going to be theta equals 0 plus pi k. So 0, pi, 2 pi. And here we're going to get inverse cosine of root 3 over 3. Okay, that's first quadrant. Second quadrant is going to be pi minus that. Third quadrant is going to be pi plus that. Fourth quadrant is going to be 2 pi minus that. So, I mean, you can use a calculator and get all these values. Decimals are ugly. Now, did any of these repeat from the last list? No. So I think we're good. We don't have to worry about any of them being indeterminate. And then E, we're trying to find the slope at the pole. So we got to figure out when is it at the pole. So the radius equals 0. And this one will be nicely simple after those last crazy ones. So 2 theta equals 0 plus pi k. So theta equals 0 plus pi over 2k. So theta equals 0, pi over 2, pi, 3 pi over 2, 2 pi. Now, if you look at the picture, let's look at the picture and see what we expect to happen. I bet we're going to get vertical tangents and horizontal tangents at the pole. Okay. So the shortcut is dy dx equals tangent theta at the pole, sine over cosine. And so, I mean, we expect 2 of them to be vertical and 2 of them to be horizontal. So when you plug in 0, pi, 2 pi, I think we get the same thing for each of those. It's going to be 0 over plus or minus 1, which is going to be 0 for those ones. So those 3 are going to be like that. And then the other ones are probably going to be the vertical ones. So if you plug pi over 2 or 3 pi over 2 in, you're getting similar values. On the top, you're either getting plus or minus 1. On the bottom, you're getting 0 every time. So you're getting undefined. So there you go. Pi over 2, 3 pi over 2. So there you go. I'm just going to put the work up for the third one. I think, I don't know. You guys should be getting the idea. You can look at my work and use that. But we just did 3 of them, beginning to end. It's the same kind of work. Some different things show up. I think you really do need a graphing calculator probably to pull off number 4. You got to solve some equations that we can't even get through algebraically like we did on these ones. Or I don't know. It just would be too much. So take a look at my work for number 4. And yeah, it's some tedious work here.